practice using Coulomb's law in a problem. This problem says a force of 0.443 newtons exists between a positive charge of 8.1 microcoulombs, or 8.1 times 10 to the negative 6 coulombs, and another positive charge of 3.22 microcoulombs. What distance separates the charges? All right, so first let's draw a rough representation. Obviously these charges will be really small, too small to see, but perhaps around an object that's big enough to see. So let's call this object this first positive charge. Charge is typically designated with the letter Q. So we'll say Q1, the first amount of charge, is positive 8.1 times 10 to the negative 6 coulombs. And then there's a second charge, also positive. We'll call it Q2. And let that dot represent the object with the charge. And it's got 3.22 times 10 to the negative 6 coulombs worth of charge on it. And we know that those two objects feel a force. They're both positive charges, so we're expecting them to repel. So this object is pushed this way, and this object is pushed that way. And in fact, we're given the amount of the force too. Since Newton's law says equal and opposite forces, those are both going to experience a repelling force of 0.443 newtons. And what we'd like to do is we'd like to say, okay, so I know the force of 0.443 newtons. I know Q1 and Q2, and I'm looking for what's the distance between those two. And the equation that links all of these variables together is called Coulomb's law. And Coulomb's law is a way of saying how much force two objects will experience. And that has a constant in there. It's also dependent on the amount that one object is charged, the amount of the second charge, and the distance between them. So essentially all you have to do is know that K is a constant. For our purposes, we round it to 9 times 10 to the 9th. And it's got these units that make the force work out to be in newtons, as long as you use coulombs here and meters there. And so we're already in coulombs, we're already in newtons, so you can expect that we'll get meters out from this. So essentially, it's really just plug and chug. We've got force, we've got both of our charges, we've got our K value, and we're just solving for distance. So you should be ready to go on that. Good luck.